Hello everyone, in today's topic we are going to talk about trigonometric ratios. So the trigonometric ratios includes sine, cosine, and function. Sometimes we can call them trigonometric functions. So we have three, the sine, cosine, and tangent. So sine, S-I-N-E, it is pronounced as sine. So the symbol for sine is S-I-N, all small letters. Then cosine, it is pronounced as cosine. The symbol for cosine is COS, is small letters. And tangent, pronounced as tangent. And the symbol for tangent is TAN, is small letters. So the Greek letter theta, so it is pronounced as theta. It represents an unknown angle. So talking about trigonometric ratios or functions, so the ratio for sine or sine theta is equal to opposite over hypotenuse. So if this is the theta, this is your opposite side and this is your hypotenuse. So hypotenuse doesn't change at all because hypotenuse is the side opposite your right angle. So if this is the theta, this is the opposite side and always this is the hypotenuse, the longest side or the side opposite to the right angle. So it is sine equals opposite over hypotenuse. Now, let's move on to cosine. Cosine theta is equal to adjacent over hypotenuse. If this is the theta, this is the adjacent side. Adjacent meaning it is the side near to the angle. And, of course, this is the hypotenuse. So, cosine theta is equal to adjacent over hypotenuse. And tangent theta is equal to opposite over adjacent. So we need a way to remember all of these ratios. So here's a way. Some old hag came around here taking our apples. Or in short, if you observe the first letter of the words, the S for some, the O for old, and up to the apples, it's A. So we have the mnemonic device, which is the so, the ka, and the toa. The so stands for sine theta is equal to opposite over hypotenuse. Ka stands for cosine theta equals adjacent over hypotenuse. And then toa stands for tangent theta equals opposite over adjacent. The SOHCAHTOA helps you a lot to remember how to solve your trigonometric ratios. Now, we are going to find sine, cosine, and tangent. So, given the diagram, we are going to use the SOHCAHTOA in order to find sine theta, cosine theta, and tangent theta. For sine theta, it is opposite over hypotenuse. So, referring this theta, so it is equal to 8 over 10, or in lowest term, it is 4 over 5. For cosine theta, adjacent over hypotenuse, so it is 6 over 10, or in lowest term, 3 over 5. Tangent theta is equal to opposite over adjacent. It is equal to 8 over 6, in lowest term, 4 over 3. Now, let us find the sine, the cosine, and the tangent of angle A. Give a fraction and decimal answer, and we are going to round to 4 decimal places. So, instead of us using theta, I use this capital letter A for the angle. So, from here, we are going to find out sine A. So, sine A is equal to opposite over hypotenuse, the so. So it is equal to 9 over 10.8 or approximately equal to 0.8333. Then we are going to have cosine A. So cosine A is equal to adjacent over hypotenuse ka. So it is equal to 6 over 10.8 or approximately equal to 0.5556. And we have the last one, tangent A is equal to opposite over adjacent, TOA. It is equal to 9 over 6 or approximately equal to 1.5. Now let us find the values of the three trigonometric functions of theta. As you can see in the diagram, the hypotenuse is missing. So from here, we are going to use the Pythagorean theorem. So the Pythagorean theorem states that c squared is equal to a squared plus b squared. So in here, if the hypotenuse is missing, we are just going to add the square of the two legs and then get the square root. So 3 squared is equal to 9, 4 squared is equal to 16, 9 plus 16 is 25, and the square root of 25 is 5. So you learned this one in your grade 8, so it's not a difficult task for you to determine the missing side. If one of the legs is missing, you just need to subtract. So from here, it is equal to 5. So therefore, now we can determine sine theta. So sine theta is equal to opposite over hypotenuse. So it is equal to 4 over 5. And cosine theta, ka, it is equal to adjacent over hypotenuse. It is equal to 3 over 5. And tangent theta, TOA. From TOA, it is equal to opposite over adjacent, 4 over 3. So that is how we find the values of the three trigonometric functions if one of the lengths is missing. Now let's move on to finding the sine, the cosine, and the tangent of angle A. So give the fraction as well as the decimal form and round to 4 decimal places. Since all of the lengths are given, so all we need to do is to determine sine A. So sine A from is equal to opposite over hypotenuse. So it is equal to 8.2 over 24.5 or approximately equal to 0.3347. And then cosine A equals adjacent over hypotenuse, the ka. It is equal to 23.1 over 24.5 or approximately equal to 0.9429. And then we have tangent A, which is equal to TOA, opposite over adjacent. It is equal to 8.2 over 23.1, which is approximately equal to 0.3550. Now let us move on to word problems. So a surveyor is standing 50 feet from the base of a large tree. The surveyor measures the angle of elevation to the top of the tree as 71.5 degrees. How tall is the tree? So in here, the first thing we need to do is to illustrate the problem. So a surveyor is standing 50 feet from the base of a large tree. The surveyor measures the angle of the elevation to the top of the tree as 71.5 degrees. And then we are going to determine how tall is the tree. So from here, from the diagram or illustration, the first thing we need to do is to identify or determine the best trigonometric function that we can use in order for us to find the height of the tree. So it is tangent. Why? Because given the theta tan 71.5 degrees, it is equal to opposite over adjacent, TOA. So opposite is missing, adjacent is given. When you are uh, solving for a problem like this, you always remember your ratio, the SOHCAHTOA. And then from that, you will gonna choose which is the best. And to choose the best, we should have only one missing given. Okay? So for example, tangent 71.5 degrees is equal to y, which is the height of the tree, over your adjacent side, which is 50. So as you can see here, only one given is missing. So from here, cross multiply. So y equals 50 tangent 71.5 degrees. And then using the calculator, y is approximately equal to 149.4 feet. So using the scientific calculator, the functions sine, cosine, and tangent are located here. And then if we are going to evaluate sine 80 degrees, all we need to do is to press sine and then press 8 and then 0 and this symbol degrees. So by pressing everything, it is equal or approximately equal to 0.9848077753. Let us have another one. A person is 200 yards from a river. Rather than walk directly to the river, the person walks along a straight path to the river's edge at a 60-degree angle. How far must the person walk to reach the river's edge? So from here, we are going to solve for x. Looking at the illustration, choose the best function that you are going to use. So we are going to use cosine. Why cosine? Because cosine 60 degrees, the theta is 60 degrees, equal to adjacent over hypotenuse. This is the adjacent side, this is hypotenuse. So it is cosine equals adjacent over hypotenuse. So from here, we are going to cross multiply, and then after cross multiplying, we are going to divide both sides by cosine 60 degrees. So we will be getting x equals 200 over cosine 60 degrees. And from here, using the calculator, x is equal to 400 yards. So that's it for now. Thank you for watching. See you again next time. Bye.